Hi, this is Ms. M. Today we have revision 2 on chapter 9, area and volume. Let's start. Here the figure shows you a snowman composed of two spheres, the head and the body. If the radius of the body is twice that of the head, while the total volume is 4 pi meter cubed, the question asks you find the radius of the head. First, we let r meter be the radius of the head, so the body is 2r meter because it is twice. By the formula, volume of sphere 4/3 pi r cubed. This is the head, while the body radius is 2r, so it's the cube of 2r. The total volume is 4 pi. So we solve this equation and find the unknown r. Or you may ask, how come this value and how come that value? Here shows you the calculation. First, this one. This means 2r times 2r times 2r, which is equal to 8r cubed. So times 4 by 8, which is 36. 32. Then how come this 12? It is 4/3. 32/3, which is 36/3 pi r cubed. So therefore, divide 36 by 3, which is 12. Hence, you simplify. Pi by pi cancelled. Divide 4 by 12. So you have r cubed is 1/3. Use the calculator and find the answer. Take the cube root. Okay. Hey girls, remind you this one. It's not divide 12 by 4. This is divide 4 by 12. So r cubed is equal to 4 pi over 12 pi. So this is 1/3, not 3, okay? So pay attention, be careful. Then the next question, question 2. There are two similar rectangles of diagonals, 5.2 cm and 6.5 cm. Draw you the figure just for reference, not in scale. A small and a big rectangle. They are similar. Diagonals. Diagonals means a line joining up the opposite vertices. So the diagonal of the small and the large. Okay. And the question asks you, if area of the large is 18.75, asks you the area of this small, how big is this small rectangle? As we know, the ratio of areas is equal to ratio of any lengths, say as the diagonals. And don't forget, it's the square if it is ratio of area. Then you substitute the area of the larger rectangle. Before you take square, you can simplify this because they can both be divided by 1.3. Hence, it is easier to take square. Okay, this is 5, that is 4. So the square of 4 and 5, which is 16 over 25. Put 18.75 to the right. Then you find the area of the smaller rectangle. Okay, let's have a look before we go to the next question. Question number 3. We have the ratio of curved surface area of 2 similar right circular cones, which is 4:9. So this is the ratio of areas given to the slant height. That means a length, a line of the larger cone is 15. The question asks you slant height of the smaller cone. As we did before, ratio of areas, 4:9 is equal to the ratio of any length, like the slant height. But remember, it's square. If on your right is area, then it's square of the ratio of lengths. Hence, you substitute the larger cone, slant height is 15. Take the square root. The square root of 4 is 2. Square root of 9 is 3. Because 3 times 3 is 9. 2 times 2 is 4. Then you find the answer. Okay. The question. Ratio of areas again. This time 2 circles. And the circumference of the larger one is 36. Then the question asks you the radius of the smaller circle. As we did before, ratio of area is equal to the square of ratio of any length, the side, say as circumference. As given in the question, ratio of areas is 25:36, while the circumference of the larger one is 36 pi. We don't want square, so take square root on the right hand side, which this is 5/6. So we can find circumference of the smaller circle. But this is not the answer because the question asks you the radius of the smaller circle. By formula, circumference of a circle, which is 2 pi r. So you can find r. The radius is 15 cm. Okay. Then the question 5. Here you can see 2 hemispherical balls. Hemisphere. Hemisphere means half of a sphere. And the larger ball is fully filled with water. The water in the larger bowl can fill up 8 smaller bowls. That means the larger ball is 8 times of the smaller ball, the volume, okay? And the question asks you the ratio of the diameter. So the diameter of the smaller, the diameter of the larger, what ratio is the diameter? As we know, the ratio of volume is equal to the cube of ratio of diameters. So we simply get the ratio of volume 1/8 because it's 8 times the small. So the small to the large, 1/8. And take the cube root because 2 times 2 times 2 is equal to 8. So take the cube root is 1/2. And hence the ratio of diameter is 1:2. Okay, the next question. Here we have a spherical snowman. And now the volume of the snowman decreases by 48%. The question asks you find the percentage decrease in the first. Find the percentage decrease in the radius. And part B, surface area. Part A first. Let RO be the original radius and R1 be the new radius. According to the question, the volume decreases. So the new volume is 1 minus 48.8% of the original. How come this number, this fraction? Show you the calculation, this one. This is equal to 51.2%. Percent means over 100. So it's 51.2 over 100. Then 10 times greater on both. So you have this value. And finally, you put this original volume to the left. So you have the ratio of volume. Remember this fraction, so you can find percentage decrease. Ratio of volume is equal to the ratio of radius, but it's the cube. So according to what we have, the ratio of volume is equal to the cube of ratio of radius. 512 is equal to 8 times 8 times 8. 1000 means 10 times 10 times 10. So just R1 to our original O is equal to this. Therefore, the new radius is equal to 0.8 ROs. Put our original to the right times. 0.8 means 80%. So which is 20% less. Then you answer the question, percentage decrease is 20% because it's only 80% of the original. 20% decrease. And go to the part B. What is the percentage decrease in area? Area of a sphere, 4 pi r squared. New surface area, so R1 squared. R1 is equal to 0.8 of the original radius. So you have this value. I'll show you how come. This one. it means 0.8 R original times 0.8 R original. So you times up for 0.8, 0.8 times them up, which is equal to 2.56, while RO times RO squared. Don't forget the value pi, okay? Then the percentage decrease is equal to nu minus O, the percentage decrease is the original minus nu over original. The nu we just got, this one. And the original, of course, is RO squared. Like this one. Hence, you have this value. How come this value? 4 minus 2.56, so it is 1.44. And of course, you may write one more line, that is 1.44 pi R squared, RO squared, over 4 pi RO squared times 100%. Okay, so you cancel the pi, you cancel the like terms pi R squared, okay? Therefore, you have this remain. Don't forget times 100%. And hence, you have the answer. Okay. Then let's go to the next one. Here, the question shows you a frustum, this below, and with the base is a right-angled triangle. With AC is 6, BC is 9, CF is 5, VF is 4. Find the length, CF is 5. Find the length VF. Consider the triangle on left. This triangle, VAC. And of course, another triangle, VFD. These two are similar triangles with the values given. This is 6, that is 4. CF is 5. The question asks you this DF. You can find using the similar triangles. Then you consider another pair of triangles, similar triangles on right. So you can find EF. Finally, find the volume. Okay, maybe let's find one by one. Part A, VF. Consider the two triangles on left. They are similar with the reason AAA because of right angles. The common angle at V. Then don't forget VF to VC. So VF is X, VC is X plus 5. So you solve for this equation and find the unknown X. So the answer VF is 10. And part B. Part B, find the length EF. Consider the similar triangles on the right. And this time is VF to VC, VF to VC, which is 10 to 15, is equal to EF to VB. EF to BC. So you substitute and find the value EF. Part C, find volume of this first one. First, find the volume of the larger pyramid. Volume of a pyramid, 1/3 times base area. The base is a right-angled triangle. So it's base times height over 2 times the height of the overall pyramid, 15, minus the volume of the pyramid above the smaller one. The base is a triangle, so area of triangle times the height VF is 10 times 1/3. This is the volume of pyramid. And finally, volume of this first one below is the difference of these two pyramids, the larger minus the smaller. Okay, this is the last example. Here you have two squares. You can see two squares. A small AEF tree, a big ABCD, and of course you have an L-shaped figure. This is the L-shaped figure. And according to the question, area of this small is 1/3 of this L shape. It means the L shape is larger than this small square by 3 times, because the smaller square is 1/3 of L shape. So in other way around, the L shape is 3 times the small. Therefore, we let the area of the small square be x. Then this L shape is 3x. Hence, the big square is 4x. Okay, understand here. And answer the question A. Ratio of these, the small to the large. So it is x to 4x. Hence, area of the small to the large. Cancel x, so you have the ratio of these areas, 1 to 4. Question B, find the ratio AE to AB. So this is the question. Find this ratio AE to dot AB. You have ratio of area 1 to 4. And the question asks you find ratio of lengths. So can you make use of ratio of areas and hence find this AE to AB? Let's think. Here it is, the answer. The ratio of area is equal to the square of ratio of lengths. While the ratio of area, we got it before, is 1/4. We don't want square, so take the square root. Square root of 1 is 1. Square root of 4 is 2, because 2 times 2 is 4. So the answer, 1 to 2. Okay, any questions? Done. This is the end of today's lesson. See you next time. Bye-bye.